Okay, so you know I like this kind of problem. Where we've got to use something from something else, where we learn something else somewhere along the line, and we've got to apply it to a new situation. So here we go. Let's look at problem 2452 here. I like this problem. This is good old Brewster's angle type problem. But first thing it asks is the critical angle between two boundaries. All right, so I've got N1 coming in, and here's N2. All right, and it's coming in at 45 degrees, and that's a critical angle. So that means it's bouncing off sorry. So I got N1 coming in like this, 45 degrees, and here's N2. All right, and here's right here. So there's N2. Now, the sine of the critical angle is equal to N2 over N1. Okay, that's what the sine of the critical angle is. So N1 times the sine of 45 in this case is equal to N2. All right, so now Brewster's angle says this: the tangent of the polarizing angle is equal to N2 over N1. Well, it looks like I've got three unknowns and only one equation. Well, we can fix this up. We do have a number here. So we'll say, well, N2 is equal to N1 times the sine of 45 over N1. And things can be polarized. I had screwed up earlier. I've already done this problem once before and did it wrong because I was thinking that you couldn't have this situation because remember, this only works when N2 is less than N1. And I thought polarization had to follow the opposite, that N1 had to be less than N2. But it's not the case. And so, hey, look what happens. So the tangent is equal to the sine of 45. Okay, well, you take it from there. You can figure it out from there. So you can just get the number, just take the inverse tangent, and you've got it out here. These are all nice. Before I take off, these are all nice problems. They're all of them are wide open for the upcoming exam. Well, we'll look at the end of 24, this polarization stuff, 25, and of course 26. All right. And I will put some of the relativity things on there too, on here.